Okay, so we're going to do solving linear equations and inequalities. First thing I wanted to show you is something, if I told you x plus 2 equals 5. How many different options are there for x? One. Okay, so this is an equation, and there's only one value for x that will make this equation true. Then I'm going to talk about the difference between a linear and a nonlinear. What is the power of this x right here? What's the power of this x? It's not written, but what's the exponent here? What's the exponent for this x?
1.
A 1, okay? So the power of this is a 1. When you have something linear, the x has a power of 1. So for here, if I told you 4x plus 8, that's considered a linear part. Something that's not linear would be, for example, the square root of x plus 1 equals 7. And you guys have studied enough parent functions to know, would this make a straight line? Is this a linear function? No, we call it the hill graph, right? This little hill. Now, this is worth the Jolly Rancher. Can anybody tell me what this x is written as an exponent? Now, that's pretty good. Do it. 2 misses. Okay, you go first.
X to the power of 1.
That's right. And we'll study it later. Okay, it's called power over root. Another way to write this, it's totally off topic, but it's so important, is x to the 1/2. This is the power, because there's a power of 1 here. And the 2 is the root, is the square root. I'll get your square in a second, that's the next word. This is non-linear, right? It will not make a straight line. And it has a power, actually, of 1/2. Okay, let's go to the next one. 2/3 x plus 2 equals 7. If you graphed it, would that make a straight line? Absolutely. 2/3 x plus 2 equals 7. How about something like this? 2 over x squared equals 41. What's the power of x on that problem? Good. So is it going to be a straight line? No. Technically it's -2, right? You actually write that x to -2 already. 0.75 x minus 4 equals 3x plus 8. That will be a straight line, right? Highest power is 1. Versus this one, 2 to the x equals 10. You may know the name of something that has an x as an exponent. We studied it. Exponential. Excellent. Okay, so here is a few problems. This is just review. And the question is to solve them. If you were going to solve that, what would the first part be? What would you do first? Distribute. Excellent. So distribute and solve for x. How many different answers are available there? How many answers do you think are going to work? Usually 1. There's a couple of exceptions, and we'll go over those. What'd you get? Okay. I'm distributing, minus 18 equals -30. Now, I know in the past you guys have had to show tons of work. Like you would say, all right, you would add 18 and add 18. We'll finish later. Okay, so I was talking about the steps that you had to make, maybe prior. So obviously we're supposed to add 18 to both sides, right? So what I wrote in pencil, it's up to you if you want to do that part written out. So I know I'm going to add 18 to both sides, which ends up giving me 6x. Okay, and then if you choose to write it or not, that's up to you. Divide both sides by 6. Again, y'all are accustomed to doing that. If you want to show that work, you can, but then the final answer is -2. How can you go back and see if you got the correct correct answer. That's the beauty of these kind of problems. Yes. Right, good. You take negative 2 and you plug it back in. Let's check. Negative 2 minus 3 is negative 5. And negative 5 times 6 is negative 30. Yes, we were right. So that's why these problems are nice. Here's your next one. 3x minus 8. 3 minus x equals 53. Again, order of operations is going to tell us to drop the 3x down and distribute the negative 8. So drop your 3x and then distribute. Which gives you negative 24 plus 8x. Watch your signs there, because that's a negative 8. Negative 8 times 3 is negative 24, and negative 8 times negative x is positive 8x. Okay? Now combine like terms and put these together. So you're at 11x minus 24 equals 53. Okay, and as far as showing your work is concerned, you're going to add 24 on both sides, which gives you 11x equaling 77. Divide by 7 on both sides, so x is 7. And again, you can plug it in to check and see if you're accurate. Let's go to the next problem.
Hey, Jimmy.
Write that one down. You can try it.
I have to ask, do I have to equal?
So distribute the 5 and distribute the negative. So you have 5x minus 40. And then you're going to, remember this is a minus here. You have to apply it to both. So minus x minus 6 equals 18. Right? And on the left side, I'm going to clean it up in one step. I'm going to put the 5x and the negative x together, which is 4x. And I'm going to put the negative 40 and the negative 6 together, which is negative 46. Right? Now you would add 46 to both sides. So 4x equals, you add 46, you get 64. And then divide both sides by 4. Okay. Here, in a minute, if you're working ahead of me, you're going to notice you get a fraction, or you can consider a decimal as the answer. Here's a rule of thumbs for algebra in general. If there's a decimal in the problem, you can write your answer with a decimal. If there's not a decimal in the problem, you should write it as a what? A fraction. So is there a decimal in this problem? No, so when you get there to write the answer, just go ahead and leave it in fraction form, okay? If you distribute on the right, 12x plus 20 equals 6x plus 24. This one I've got an x on both sides, so I'm going to move the 6x to the other side, remember? And put all the x's on one side together. So if I do minus 6x, that's what I'm essentially doing. So 6x plus 20 now equals 24. If you move your 20 over, you end up with 6x equaling 4. Divide both by 6, and x is 4, 6, which reduces to 2/3. And you would leave it as 2/3. Here's your next one. FOIL your negative 4, which gives you a positive 20. Watch the negative, right? Negative 4 times 2 is negative 8n. Negative 4 times negative 5 is positive 20. And you end up with negative 8n plus 20 equals negative 8n minus 20, which if you notice at this point, that obviously cannot be true. But in case you missed that, it's okay. When I tried to add 8n to both sides, plus 8n, what's going to happen? They go away. So you end up getting 20 equaling negative 20. Is that possible? No. So what is that telling us? What does this mean?
Impossible.
Yeah, there's no solution. Either way, you can write it either way. There's no solution. Now, on the same note of that, guys, that's like saying this is very basic. They kind of doctored it up and made it look pretty, but could x plus 2 ever equal x plus 3? That's what that's saying. It's fancier, but it's basically saying this. This doesn't work. There's no solution. Okay? I threw a fraction in here. I'm determined to get as good fractions, okay? Once you've done enough of them, then they're not scary anymore. So, in this problem, drop the 2x down and then distribute the 4. Plus 4x plus 4 equals, and on the right, you're going to distribute the 6. So 6x, and then over here, you've got 6 over 1 times 2/3. That's essentially what's going on. Some kids may just want to put this over 1 and not write it over to the right. It's up to you on how good you are at it. Okay, and then you end up with 6 times 2 is 12. So you get 12 over 3, which is how much? 4. Or you can simplify first. You still get 4. However you want to do it, the answer is 4. Okay, we're going to clean up the left side. 2x and 4x makes 6x plus 4. Wait a minute, what are you noticing now? What are they? They're exactly the same, right? So even if I cancel my 6x, if I did minus 6x, I get 4 equals 4. What do you think the answer is going to be in this situation? All numbers, everything works. Here's a basic concept of y. Watch. Here's a little think bubble for a second. If I told you x plus 2 equals x plus 2, right? It wouldn't matter what I put in. I put a 1 in here, now I've got 3 equals 3. I put a 5 in, 7 equals 7. A 10, 12 equals 12, right? So they're the same thing. All they did was make one side look different than the other. So, for example, if I told you 2x equals 4 over 2x, don't they both equal 2x? Yeah, they just look a little different. That's all they did. They made one side look different than the other, but they're still the same. Once you kind of reduce and simplify. All right, we're going to switch topics now. We're going to move to inequalities. And the directions are solve and graph. We talked about it in an equation. Okay, for example, if I told you x plus 2 equals 5, then x is 3, right? We discussed that, right? But sometimes when you change the equal to like a less than or greater, actually there's lots of different answers, right? So that's what's going to happen here. For example, if I told you, and we'll just think about this for a second, x plus 2 was greater than 5. We move the 2 over, and it means x is greater than 3. Every number bigger than 3 is going to work here, right? You can test it out. Will 3 work? Let's check. 3 plus 2 equals 5. That won't work, every number bigger than 3 works. Right? Try 4. 4 plus 2, is it bigger than 5? Yes. 5 plus 2 is bigger than 5, right? You see what I mean? So in an inequality, instead of just one answer, because I want it to be equal, it has to be exactly perfect. If you change your equal to less than or greater than, lots of answers actually work. And that's what we're doing here. Alright, so we're going to solve the first one, and they're solved the same way. You just act like it's an equal sign. Here's your first problem. What are you going to do to both sides? First, add how much? 12. So now you're at 5x is greater than 20. Then you would divide both sides by 5. So x is greater than 4. That means, would 4 work in this situation? If I put 4 into here, 20 minus 12 equals 8. 4 won't work. But all numbers bigger than 4 will. 5 will work, 6 will work. So then it tells me to graph right here. Now, it just means graph on a number line. We don't have an x and a y, so we can't graph a line. But, so draw yourself a number line and represent all numbers bigger than 4. Okay, every time you draw a number line for me, guys, do me a favor and put 0 there so that I can kind of have a relative to the problem. And it doesn't have to be to scale or anything. Now then we need a 4, so here's my 4, and I want all numbers bigger. A greater than means you want an open circle, and then you go to the right. Okay, the next one, you kind of tuned me out. This one's harder. Tune me back in. This one is a harder problem. It's a little more new. Okay, what's weird about that problem?
It's 2 things.
It's got 2 things. I kind of think about it as a seesaw, and someone's also sitting in the middle. Okay? So the middle right here is where your x is, but you've got somebody on both sides too. And it wants the whole seesaw to be flat. So I take something out of the middle to keep it balanced. I'm going to need to take some out of this side and out of this side, right? If I add something to the middle, I need to add it to the left and to the right. That's kind of how to look at this. This is saying x is between these 2 numbers. So if I want to whittle my way down to x, every little change I make has to be made here, middle, and right. Do you see what I mean? It looks different, but it's really not too hard. I'm going to do 2. Let's try this one first. Okay, I'm solving for x. So I'm going to think about, this is the part I'm trying to get cleaned up. So I need to get rid of the 3 and the 5. Which one do I get rid of first? The 5. Okay, and I'm actually going to show my work on this one. Okay, I'm going to say, all right, plus 5 here, it goes away. But if you take something out of the middle, and I still want a balanced beam, I need both sides out too. So I'm going to add 5 here and add 5 here. Are y'all seeing it? We're kind of looking at this part like it's like an island. So you end up with 3 is less than, 3x is still left in the middle, and then 12 on the right. Now again, I'm solving for x. What are you going to think I'm going to do next? Divide by 3, but I need to divide it all. The right, the left, and the middle. I've got to keep it balanced. Okay, they're really not bad once you see them. They just look funny. Divide everything by 3. 1 is less than x, which is less than 4. That just means, guys, that numbers between 1 and 4 make this true. It needs to be a number bigger than 1 and a number less than 4. Right? X is between, x is in the middle of 1 and 4. So draw a number line. What did I tell you to always put on the number line to help us out? Good. Y'all are awake. It's amazing. 0. And then I'm going to add a 1 and a 4. Open circle of both in the middle. That's all numbers between 1 and 4. I'm going to do one more like that and see how you can do with it. There's an equal to sign there. Don't worry about it. Just work it the same way. Give it a shot. You should subtract 4 first, right? Right, I'm going to show my work on this. Subtract 4, and subtract 4. Which gives us negative 11 is less than 3/4 x, which is less than or equal to 9. I've discussed this with you a couple of times, but once again, what's the best way to get rid of that fraction? Rather than divide it by 3/4, what's a better way? Multiply by 4/3. Multiply by the reciprocal. It's cleaner. It saves a lot more time. So let's multiply by 4/3 here, remember this over 1, on the left, and on the right. On the left side, I can't reduce anything, so I just get negative 44 over 3. Are the fractions getting easier? Yeah, I think they seem to be better at them. This is going to give me x. I can reduce here. This is a 1 and a 3, which gives me 12. Now build your number line. Reach your 0. It doesn't have to be to scale. What needs to be on top of 12 though? Excellent. A closed circle on top of 12. Why? Good, because of the equal sign. Because of this right here, this has to be closed. I'm going to do a problem, and it's more of a, hey, remember this, okay? Because there's going to be some on your practice. It's kind of the same thing that we're doing. If you're going to solve this, it looks like a proportion, right? Does anybody remember, and I know it's been a while, but what's a cool way to solve a proportion? There's 2 fractions. We're not thinking about a proportion because we didn't turn a word problem into a proportion, right? But that's all 2 fractions are. Do you remember how to solve them? Yeah. A lot of kids call it the butterfly method, right? Do y'all remember that? And if you'll remember, if I told you that 1/2 equals 2/4, if I said 1/2 equals 2/4, we know that they're equal because 2 times 2 is 4 and 1 times 4 is 4. It's called the butterfly method. Right? Some people might have done the arrow method, whatever. What that means is that this side is negative 13 times 3, doesn't matter which way you start, equals this side, which would be 3 times all of that. Remembering it now? Take good notes if you didn't. And then now you can just solve for what? Solve for x. So you end up with negative 39 equaling 15x plus 6 when we redistribute. Move your 6 over. Divide by 15. And x is negative 3. Okay, so now a little bit of practice with word problems, and we'll do more and more as we get into like quadratics and stuff. But would you do me a favor? Read problem 7 and try to set up an equation that you can solve. I'll give you a hint. The thing that gets the variable is the thing that repeats.
Or it's the thing that can vary.
Mm-hmm. That's a good way to think about it. Something that can change. Alright, so taking a look at 7, does anybody want to tell me what they wrote? What's it start with? What is it going to equal? How much is the total amount that the bill is? Oh, practically. Okay, so it equals 1456. And how did the kid or whoever's working the phone, how do they get to that amount? What do they have to start with? What charge is there all the time no matter what? Excellent, $12.95. Don't be scared of word problems. You can kind of dissect them. And then they have to add something. What do they add? How much per minute? 7 cents a minute. And that's what gets the variable because it changes. If I was going to talk for 1 minute, I'd plug in a 1 here. If I was going to talk for 10 minutes, I'd plug a 10 in. Do you see how it changes? Okay. Right. We're running out of time, but there's the last one. You can try it. Make it really quick in 1 minute. We're going to stack cups. We're in a total of how much? 14. Each cup is $3.25 plus 0.25 per cup.